So in this video, we'll be discussing the concept of the atmosphere or the ambient air using the ideal gas model. So ang una nating i-discuss dito ay yung relative humidity. So relative humidity is the ratio between the pressure of water vapor in the atmosphere over its supposed saturated vapor pressure. So ano yung saturated vapor pressure? So that is the maximum amount of water vapor that can be associated in the atmosphere or that can mix with the air components in the atmosphere at a given temperature. So, hindi ko naman sinasabi na since maximum siya, hindi na pwedeng madagdagan. Pero yun yung setting natin sa 100% relative humidity. So, kapag ganun na yung pressure ng water vapor dun sa system, that is our parang basis for the 100% relative humidity. Okay, so if you look at this table, makikita natin yung mga saturated vapor pressures. So at 20 degrees Celsius, you see that the saturated vapor pressure of water is 17.5 millimeters mercury. So kapag 17.5 millimeters mercury na yung pressure ng water dun sa system, ibig sabihin, 100% na yung relative humidity. So kumbaga, saturated na yung air. Parang sa solution, okay? So, pag sinabi mong saturated na yung solution, if you add more of the solute, precipitate na sila. So, ganun din yung water. At normal conditions, if you are beyond the 17.5 millimeters mercury in this case, okay? So, kapag lumagpas ka dun sa saturated vapor pressure, magpe-precipitate na yung ibang water particles. So, either magmo-moist sila, okay? Magdidikit sila sa mga surfaces, or magpe-precipitate sila as rain. So usually yung rain, nangyayari yun kapag nagkakaroon ka ng drop dun sa temperature. For example, from 30 degrees Celsius, nagiging 20 degrees Celsius. So ibig sabihin, yung saturated vapor pressure from 31 nagiging 17.5. So yung difference ng pressure na yan, those are water particles. So it's equivalent to a certain number of moles of water particles. So, yun yung either magmo-moist dun sa paligid or sila yung magpe-precipitate as rain. Okay? So, it's regardless of the volumes. Kasi ito ay, pinag-uusapan natin dito ay pressures. Okay? So, the percent relative humidity is equal to the 100% times, okay, the pressure of water in the atmosphere over the saturated vapor pressure of water. Okay? So, usually, ang kinukuha natin dito ay yung pressure ng water or the relative humidity. So, the saturated vapor pressure of water is usually given. Okay? So, nandun siya usually sa table. Okay? So, beyond this point, nagkakaroon ka usually ng mas mataas na relative humidity kapag ka sobrang stable ng air. So, ibig sabihin, pwede ka magkaroon ng supersaturated solution. Pag naman unsaturated, ibig sabihin, less than 100% ang iyong relative humidity. Okay? So, take note that air is composed of the dry part. Okay? So, meron tayong dry air. This is the dry air. Okay? Bugay ko lang yung color. Dry air. So, dry air is composed of the other gas particles aside from water. Okay, so nitrogen, oxygen, argon, and carbon dioxide. Usually, some other noble gases like helium, okay, and neon. Pero, ang nagdo-dominate na gases dyan sa dry air ay yung nitrogen and oxygen. So, usually, sa mga problems may encounter nyo, nitrogen and oxygen lang yung binibigay na components ng air. Kasi usually, hindi na masyadong significant yung composition ng ibang gases. Okay? So, that is presented usually in mole percent. So, ibig sabihin, kapag mole percent, that's just the mole fraction. So, mole percent is equal to mole fraction times 100%. Okay? So, that's the mole percent. And, let's take note, okay, yung ating P of air, yung lahat ng air, yung ambient air, is equal to P dry air plus P H2. So, the pressure of air or the ambient air is equal to the pressure of dry air plus pressure of water. So, this is based on Dalton's law of partial pressures kasi kinoconsider natin yung mga gases na to as ideal. So, sumusunod sila sa Dalton's law. Okay? So, sample problem. The pressure of air at 30 degrees Celsius is 0.95 atmospheres. The percent relative humidity is 80%. So assume that dry air contains 79% N2 and 21% O2 by moles. So first, calculate the pressure of water vapor. So based on the table kanina, ito yung kanyang saturated vapor pressure at 30 degrees Celsius, 31.8 millimeters mercury. So meron din tayong conversion factor dito na 1 atmosphere is equal to 760 millimeters mercury. So for this problem, we use percent relative humidity is equal to 100% times pH2O over P star H2O. So ito yung ating hinahanap. Okay? So rearranging this equation para ma-equate natin siya sa pH2O. Okay? So the pressure of H2O is equal to the saturated vapor pressure of H2O times the percent relative humidity over 100. So if you calculate this, okay, meron tayong percent relative humidity na 80% over 100. The saturated vapor pressure is given here na 31.8. So makukuha natin ay 25.44 millimeters mercury. If we convert using this conversion factor, makukuha natin ay 0.03347 atmospheres. So that would be the pressure of water in the system. So next, calculate the pressures of N2 and O2. So step by step natin siyang gagawin. First, determine the pressure of dry air. Kasi this particular composition here is the dry air composition. Okay? So ihiwalay muna natin yung water dun sa equation. So, discuss ko kanina that the pressure of air or the ambient air is equal to the pressure of the dry air components plus the pressure of water. So, the pressure of dry air is equal to the pressure of the ambient air minus the pressure of water, 0.95 atmospheres, that's the total pressure, minus 0.03347 atmospheres, that's for water, that's equal to 0.91653 atmospheres. So, that would be the pressure of your dry air. So after determining the pressure of the dry air, you can now calculate the pressures of nitrogen and oxygen. Again, percent by mole or mole percent is equal to the mole fraction of the component times 100%. Okay? So, therefore, the mole fraction of N2 is 79% over 100. That's 0.79. The mole fraction of O2 is 21%. So, 21% over 100 is 0.21. Therefore, the pressure of O2 is equal to the mole fraction of O2 times the pressure of dry air. So, that's 0.7240587 atmospheres. So, Pn2, or the pressure of N2, is equal to the mole fraction of N2 times P of dry air, is equal to 0.1924713 atmospheres. So, that's how you calculate the pressures of the dry components. Hihiwalay nyo muna yung pressure ng dry air dun sa pressure ng ambient air by subtracting it from or subtracting it by the pressure of water. Okay? So, next, we have this particular problem. Okay? So, assume that the dry air is composed of 79% N2 and 21% O2 by moles. The pressure at sea level is 0.945 atmosphere, and the percent relative humidity is 80%, and the temperature is 30 degrees Celsius. So, given na tayo ng pressure at sea level, meron na tayo temperature at sea level, meron tayong percent relative humidity. We also have the composition of O2 and N2, the dry air system. Okay? So, letter A, calculate the vapor pressure of water. So, this will be easy. Okay? Ito na yung ating saturated vapor pressure based dun sa table kanina. So, the saturated vapor pressure at 30 degrees is 31.8 millimeters mercury. You use the percent RH is equal to 100% times the pressure of H2O over its saturated vapor pressure. Calculating for the pressure of water, we have 25.44 millimeters mercury, or the 0.0335 atmospheres. Next, calculate the molar mass of the moist air. So first, we should take note that in the dry air, okay, we have the mole fraction of O2, which is 0.21, and the mole fraction of N2, which is 0.79. Again, mole percent, okay, over 100 is equal to the mole fraction. So step by step, the first step is to calculate the mole fraction of O2, N2, and H2O in the moist air. So take note that the mole fraction of O2 and N2 here are just for the dry air. Kailangan nating malaman yung mole fraction nila sa moist air. Okay? Kailangan mole fraction nila kapag included na sila dun sa moist air. Okay? So the pressure of moist air is pressure of the dry air plus H2O, or pressure of H2O. So therefore, the pressure of dry air is equal to pressure of moist air minus pressure of water. So pressure of dry air is equal to 0.945 atmospheres minus 0.0335 atmospheres. You'll get 0.9115 atmospheres. So the pressure of nitrogen in this system is the pressure of N2 in the dry air, which is 0.79, times the pressure of dry air, which is 0.9115 atmospheres. So that's 0.79 times 0.9115, we'll get 0.720085 atmospheres. So the pressure of O2 is the mole fraction of O2 in the dry air. So this is 0.21, okay, times the pressure of dry air, which is, again, 0.9115. So 0.21 times 0.9115, that's 0.191415 atmospheres. So, since alam na natin yung mga individual pressures nila, we can actually get, okay, the mole fraction of N2, O2, and H2O by dividing their individual pressures, okay, to the pressure of the moist air. Kasi yung pressure ng moist air, yun yung total pressure. The individual pressures are their partial pressures. Okay? So the mole fraction of N2 is equal to the pressure of N2 as calculated here over the pressure of moist air, which is 0.945 atmosphere. Okay? So you'll get 0.762. That's dimensionless kasi na-cancel yung atmosphere. So that's mole fraction of O2 is equal to 0.203 based on this equation. Pressure, or the mole fraction of H2O is pressure of H2O over pressure of moist air, that's 0.035. So the next step is to calculate the average molar mass. Okay, so makikita natin dito. Okay, so I'll just change the color of this para makita natin yung ating mga molar masses. So for O2, that's 32 grams per mole. The N2 is 28.02 grams per mole, while for O2, that's 18.016 grams per mole. So if you calculate the average molar mass, you'll have to multiply the mole fractions given here, okay, by the respective molar masses given here. So average molar mass is mole fraction of O2 times molar mass of O2 plus mole fraction of N2 times molar mass of N2 plus mole fraction of H2O times molar mass of H2O. You will get 28.4778 grams per mole. Okay? So, you now have the molar mass of the moist air. So, next is calculate the density of moist air. So, the density of moist air based on PV equals nRT. Okay? Ang kukunin nyo lang dyan, ang tatargetin nyo kunin dyan is yung mass over volume. That would be the density. Okay? So, deriving PV is equal to mass over molar mass because N, okay, is equal to mass over molar mass, okay, RT. So, rederiving to get the M over V, okay, density is equal to M over V is equal to the pressure of the system times the molar mass of the system over R times the temperature of the system. So, yung pressure nito, this is the P atmosphere, or the pressure of the moist air. The M is the average molar mass given here, okay? Temperature is the temperature of the system, which is 30 degrees Celsius. So, convert nyo na lang sa Kelvin. So, these are the substitution values. 0.945 atm times 28.4778 grams per mole over R, which is 0.8206 or 0.08206 liter atmosphere per mole Kelvin, times 30 plus 273.15 Kelvin. So, 30 degrees Celsius plus 273.15 to convert it to Kelvin. you will realize that the density, or you will calculate density to be 1.082 grams per liter. Okay, so this is how the calculations work out for the atmospheric model if you are using the ideal gas equation. So iba syempre ang set of calculations kapag hindi ideal gas equation yung gamit. Okay? And the calculations will be more accurate kapag kino-consider natin yung ibang properties ng gas like its molecular volume and its IMFA. Pero in this case, I'll just have to demonstrate how ideal gas models or equations of states are used to be in this case in the ambient air or the atmospheric model. Okay, so see you next video.